Question 25, RK Bali. Aircraft is on a heading of 230. RBI shows 040. What is the magnetic bearing of aircraft? From NDB, variation is 5 west and 6 west at NDB. So very simple, sir. Aircraft heading is given to you in magnetic and RBI, relative bearing indicator, shows 040. So your relative bearing given is 040. You are asked to find magnetic bearing from the station. Magnetic bearing from the station means you have to find. So magnetic bearing from the station is your QDR. Is QDR. Magnetic bearing from the station equals to QDR. Is QDR. So now let's check the basics. Let's say this is your NDB station. This is your NDB station, right? And this is your track to the NDB station. Inbound track to the NDB station. Inbound track towards the NDB station. Magnetic track. Let's say magnetic track. So this will be called QDN. So this is your null datum. So QDM will be in this case, if you want to fly inbound, 090, 090. Let's say you are flying towards the NDB and there are no wind conditions. We are taking that there are no wind conditions. So in no wind conditions, you will not have to apply any kind of crosswind technique. So the heading of your aircraft will be 090. The track will also be 090. The heading of aircraft will be 090 and the track will also be 090. Now relative bearing. What is relative bearing? Relative bearing is the angle between heading of aircraft and QDM or track towards the station. Relative bearing is the angle between aircraft heading and the track towards the station. Measured from aircraft measured from aircraft heading. Measured from aircraft heading. So that is your relative bearing. So it is always measured from heading towards the track that will take you towards the station. Now in this case, when heading is also 90, track is also 90, the angular difference between them, which is nothing but your relative bearing, is 0 degree or 360 degree. So that means 0 degree or 360 degree implies that the NDB station is directly in front of the aircraft, in front of this aircraft, directly in front of the nose or in front of the longitudinal axis of aircraft. That will be more appropriate way. The NDB station is directly in front of longitudinal axis of aircraft or the heading of aircraft. Now let's say this is for no wind conditions. Now let's say in the next example, the same NDB station is here. The same track we are taking QDM magnetic track towards the station 090. But in this case, I am putting crosswind conditions coming from aircraft's left hand side. Coming from aircraft left hand side. So this was our aeroplane previously on a QDM track of 0990 towards the NDB station. Left crosswinds are coming. Now left crosswinds, when aeroplane flies in an air mass or in the atmosphere, now this atmosphere is constantly in motion. So if this atmosphere moves from left to right hand side, it will also take or push that aircraft to right hand side, or it will try to take that aircraft along with itself. So if it's very necessary that we apply crosswind technique or crosswind correction. So if the winds are coming from the left hand side, to correct that, or to in order to prevent drifting or to avoid getting drifted, you should point your aircraft heading a little bit into the wind, a little bit into the wind. Instead of aligning your heading along this track of QDM 0900, now I have headed my plane, that is the longitudinal axis of aircraft, a little bit into the wind, a little bit into the wind. Okay, and the track of aircraft, which is this track of QDM 090, stays the same. So aircraft will still continue flying. Aircraft will still continue flying along this track towards the NDB, but the direction of its longitudinal axis or heading will be a little bit tilted towards left hand side into the wind. Okay, so this is how a crosswind correction is applied. Now again, coming back to our definition, that relative bearing is the angle between heading of aircraft and the track towards the station. Track towards the station. Relative bearing is the angle between heading of aircraft and track towards the station. So this is the heading of aircraft. Let's say now, let's say the heading is somewhat less than 090. When you turn left, heading decreases, angles decrease. When you turn right, angles increase. So in this case, I am taking it heading of 080, and the inbound track is 090. So now you will start measuring your relative bearing from the heading of aircraft, from the heading of aircraft. So starting from here up to here. So this will be how much, starting from 0 and 0 degree angle, and then this angle, total angle will be 90 minus 80, which is 10 degree. Just the 10 degree, not 10 degree magnetic or 10 degree true, no, just 10 degree is your relative bearing. So that means relative bearing is 10 degree, right hand side, all angles are measured clockwise. So that means the NDB station is located 10 degree to the right of aircraft heading, 10 degree to the right of aircraft heading. Okay, so this is what it says. Now there is also a formula of magnetic bearing to the station, also known as QDM, to be equal to relative bearing plus magnetic heading. So in this case, what was our QDM or magnetic bearing to the station? 090, right? Inbound 090. Relative bearing we will find out. Heading, what is magnetic heading of aircraft? 080. So relative bearing is 090 minus 080, which is degree, 010 degrees. Okay, so this formula also you can use, and or diagrammatically also you have to understand it like this for better concept clarity. So this is how you should use this formula. Now next example I am taking is, this is your NDB station, same QDM 090 is your inbound track. You are looking for flying towards the NDB, and your aircraft is properly aligned with the track. Aircraft heading is properly aligned with the track towards the NDB. Now, previously we had winds coming from left. Now I'm putting winds which are right crosswinds. So now this right crosswinds will push your aircraft to the left hand side. So to avoid that, you will have to point your aircraft into the wind. You will have to point your aircraft into the winds. Longitudinal axis of aircraft into the wind. Okay. The track towards the station of QDM still remains the same, which is 090. The heading of aircraft will now be more than 090. Let's take it to be 120 degrees. 120 degrees. Now, what is relative bearing? Relative bearing is the angular difference between aircraft heading and track towards the station, measured clockwise from aircraft heading. So this is your aircraft heading. Now you have to start measuring it from heading in clockwise direction, not anti-clockwise, clockwise direction. So meaning starting from here, like this. Okay, starting from aircraft heading and then going clockwise. Now this complete circle would have made 360-degree, but we have not completed that circle. We have stopped here at this position. We have stopped at this position, that is QDM 090. Okay, so relative bearing will be how much? It will be entire circle would have made a 360-degree, but we have not made that entire full 360-degree circle. So we will subtract from that this this portion. Now this angle is how much? This yellow angle, 90 and 120 difference, which is 30 degree, which is 30 degree. So out of this whole 360 degree, I will subtract 30 degree. So my relative bearing now will be 330 degree. My relative bearing will be 330 degrees. Okay. So this is how it is done. So with left crosswind, it is like this. Starting from heading, so 010 clockwise. In case of right crosswind, don't go anti-clockwise, go clockwise. So this will be 330 degrees, which is 360 minus 30. So now let's take another example in which you are flying away from an NDB. You are flying away from an NDB station. You are flying away from an NDB station. That means your magnetic track away from the station, which is QDR, will be 270 degrees. 270 degrees. And we are taking this to be happening in no crosswind conditions. That means the calm conditions exist. No crosswinds. So in that case, the heading of your aircraft will be the same as the track of your aircraft. The heading of aircraft will be the same as track of aircraft away from the station 270. Now whenever you draw QDR, also draw QDM, which is track towards the station. Same goes with VOR. So QDM is towards the station 090 degree inbound. Now relative bearing is the angular difference between your aircraft heading and QDM, track towards the station. Track towards the station. That is your relative bearing, the angular difference between them. So in this case, the relative bearing will start from heading of aircraft clockwise towards the QDM up to here. Okay, clockwise, starting from heading clockwise up to QDM. So this is a semicircle, the angle of which is how much? The angle of which is 180 degree. So in this case, the relative bearing is 180 degree, meaning you're flying directly away from the NDB station and the NDB station is directly following behind you. It's directly behind you or behind aircraft longitudinal axis or behind the heading of aircraft. In the previous case, when NDB was lying straight ahead of the longitudinal axis of aircraft, we had a relative bearing of 00 degree or 360 degree. Now, when it is lying completely behind your aircraft heading, the relative bearing will be 180 degree. Now, let's put some crosswinds in this. So, this is your NDB station. So, we'll take a new slide. This is your NDB station. Same tracking away from the station QDR 270. We have left crosswinds. We have left crosswinds. Now, when we have left crosswinds, this crosswinds will try to push your aircraft the right hand side. It will try to push your aircraft to the right hand side. This is your aircraft. So initially we are aligned with the track away from the NDB, which is QDR. In order to prevent drifting, we will point our aircraft nose into the wind. We will point our aircraft nose into the wind. That is, we will put the heading of aircraft pointed into the wind, in the direction from where the wind is coming. Okay, so this is the track away from the station QDR 270. The heading of aircraft is, now when you go left hand side, okay, the heading you will see has shifted left hand side. So heading angles decrease. So it will be, let's say, 260 degree. 260 degree. Whenever you draw QDR, also draw QDM towards the station, the track that will go towards the station, which will be 090 degrees. Now, what is relative bearing? Is the angular difference between aircraft heading and track towards station. Towards the station. That is the definition. Now, let's start measuring this relative bearing. This is the heading of your aircraft. Go clockwise. So this point. Okay. To this point. Now we know this is the extra angle. This is the extra angle form, right? This, from this point to this point, we know the angle is, we know that the angle is 180 degree. Now we have, in addition to that, now we have this another small angle this much. Okay, we have another small angle this much. This angle will be added to this 180 degree angle. Now how much that angle is, the value of that angle is 270 and 260 difference. 270 and 260 difference, 10 degree. So relative bearing will be 180 degree plus 10 degree, which is 190 degree. So that means the station, NDB station, is located at a relative bearing of 190 degree from the heading of aircraft. So this 10, this much 10 plus the entire 180, which is 190. Now this is the case with left crosswinds. Let's say we have right crosswinds. This is your NDB station. QDR is 270. QDM is 090. Winds blowing from right hand side trying to drift your aircraft to left hand side. So the crosswind technique will ask you to fly in a crabwise manner with your aircraft nose pointed to the right hand side where the wind is blowing from. Longitudinal axis is pointing to the right hand side. The track away from the station is QDR. The heading of aircraft, now when you go right hand side, when you turn right hand side, heading increases. Let's say it's 290 degree. 290 degree. So the angular change that you have made is 20 degree. You have made is 20 degree. Now relative bearing, which is the angular difference between your aircraft heading and QDM, is how much? Starting from heading, go clockwise. This much. Now this entire thing will be 180 degree. But we have not started our measurement from this point. We have started our measurement from the point above, from here. If we had started from this red point, the entire angle would have become 180. But we have eliminated a small part of 20 degree from that entire 180 degree. So our relative bearing becomes 180 minus that small part 20, which is 160 degrees. 160 degrees. So that is your relative bearing. Okay, so we have seen 4 examples in which the 2 of which involves airplane flying towards the NDB station, airplane, and then other 2 airplane flying away from the NDB station. And all these 4 examples were related to crosswinds. And another 2 examples, each one in which aeroplane is going towards NDB and another in which aeroplane is flying away from NDB. Okay, nil wind conditions. Now let's look at the question. The question states, aircraft is on a heading of 230. RBI shows 040. What is the magnetic bearing away from NDB? So to do this, 230040. Formula is magnetic bearing to the station. We have seen this formula before. Relative bearing plus magnetic heading. Relative bearing is 040. Heading of aircraft is 230. So magnetic bearing to the station will be equal to 270 degrees. Magnetic bearing to the station will be equal to 270 degree. We have been told to find or asked to find magnetic bearing from the station. It will be reciprocal of magnetic bearing to the station. 270 minus 180 is 090 degree. So this is the answer, 090 degree. Let's draw this. NDB is here. We have QDM 270, QDR 090. QDM, that is track towards the station 270. Aircraft is headed at a magnetic bearing of 230 or direction of 230. Aircraft heading is 230. 230 is southwest heading. So I am drawing this diagram somewhat like this. Okay. Track towards the station is QDM, same 270 towards the station. Away from the station is QDR. Heading is 230. Now what is relative bearing? Angle between heading and QDM, track towards the station. Measured clockwise starting from the heading. So this is your heading, start clockwise is angle. So this angle will be how much? 270 and 230 ka difference. So which is starting from the heading. So heading will be your 00. This is the starting datum. So starting from here, the angle will be 40 degree. 040 degree. Okay, so which is this 040, 090, 270, heading 230. So this is how you diagrammatically represent this. So this is how you do the question number 25. I hope you have understood this question. Let me know your questions in the comment box. Very simple question and very frequently asked in the exams. The VOR system is limited to 1 degree accuracy. 1 degree at 200 nautical miles represents a width of how many miles? So that means the VOR is limited to 1 degree accuracy. Suppose you are situated on radial 090. The VOR system, the airborne equipment in your aircraft, the OBS selector, okay, should also indicate correctly, give you the correct indication of that. That is radial 090. But no system is perfect. So there is always an error. There is always some range of accuracy given. So for here the question states that the accuracy limit is 1 degree for this particular VOR. So it may happen that although you are on radial 090, your the OBS selector or the CDI indication given to you, that is the airborne equipment, will be plus 1 degree minus 1 degree. So although you are on radial 090, the airborne equipment may indicate to you that you are on radial 089 or radial 091. Okay, so this is how it is 1 degree accurate. So the error in the readings will be plus or minus 1 degree. So next, if this is your VOR, this is your radial, let's say radial 090, okay, and the error is 1 degree accuracy, right? And the system tells you instead of 090 you are on radial 091, okay, due to that error. So the angular difference between this angular error is 1 degree. Now due to this error, you will be told that you are on radial 091. You are on radial 091, okay, and therefore the this you have to find out the cross track limit or this range or the distance of this cross track, the difference between radial 090 and 091 at 1 degree. So if you are 1 degree diverted or if there is an error of 1 degree, what will be the spatial distance between these two radials? Now this is a good example of 1 in 60 rule, this triangle, where this side of the triangle is your distance gone, distance traveled. This side of the triangle is distance off track. Okay, so angle equals to distance off track divided by distance gone into 60. Okay, Angle is 1 degree. Distance of track is what we have to find out. The width, okay, the distance of track. The distance gone is 200 nautical miles. X is 200 divided by 60, which which is equal to 0.3 nautical mile. So the distance of track, or the answer to this question, is a width of 3.3 nautical mile. So this is how simple this sum is. Okay, so just follow the 1 in 60 rule and solve this sum. So I hope we have understood this sum. Practice this sum many times. You will find these sums in RK Bali, in many other chapters too, and also in Keith Williams and Oxford. Practice those questions also.